This is a very simple problem related to chapter number 1, 1.2. And the state that f a and b are two non-conditions that satisfy the condition ab commutation with a and ab commutation b is equal to 0. Then show that e to the power a plus b, which is equal to this, or this. So let's start from this, and we consider f of alpha, which is equal to e to the power alpha a dot e to the power alpha b, and differentiate this with respect to alpha. Then we can get, this is a product rule, then we can get this term and this term. And further, to solve this problem, this term can be added or subtracted. So e to the power minus alpha a and e to the power alpha b. So this can be cancelled out if we want to do so. Because we have done this by taking e to the power alpha a and e to the power alpha b common to the right hand side. So here we have this term and we have this term. So we can take this outside, and we have this term. And we know about this. This is f of alpha. And let's say this is equation number first. Now come back to this term, e to the power alpha a plus b e to the power minus alpha a. By expanding, this is a well-known relation, and we have already discussed about this. If we have this kind of relation, then we have b plus alpha ab plus this, we know about this, and this term already given, which is equal to 0. So we have b plus alpha ab, this term. Putting this value in equation number 1 here, because e to the power alpha a, b e to the power minus alpha a. So this term we have calculated like this, and putting this value here in equation number first, and f of alpha as it is. Now, if we take this f of alpha to the left hand side and this for derivative to the right hand side, and then integrating this equation. If we integrate this equation, then from the left hand side we can get log of f of alpha, and by taking integration of this is equal to a alpha plus beta b alpha plus alpha square, and this term. And further, if we remove the log term, then f of alpha, and this goes to the exponential term. So this goes to the exponential, and this goes to the exponential. Now further, if we take alpha is equal to 1, then it means that f of 1, which is equal to, because f of alpha is equal to this. If we consider alpha is equal to 1, then f of 1, which is equal to 1, 1. So we can get e to the power a, e to the power b. So this is very clear. And f of 1, which is equal to this, and f of 1, we know about this, that this is e to the power a, e to the power b, e to the power a plus b, and this term. And from this equation, we need to find out this e to the power a plus b. Then we must take this term to the left hand side, and finally we can get e to the power ab, which is equal to e to the power, this must goes to this side, then must the negative value, and this term. So this is proved. We have proved this, that this is equal to this. Now if we change the order of e to the power a, e to the power b, then the sign must be changed. So if this is e to the power a and e to the power b, if we change, then the sign must be changed. So we can get positive term.